Welcome to Science Encyclopedia College. This is lesson 3 on kinematics. In lesson 1, we looked at what kinematics is all about. Lesson 2, we looked at Newton's laws of motion. Please do me well by going back to check those two videos rather, what kinematics and what the Newton's laws of motion are all about, so that you can fully understand the concept behind kinematics. Now today we are going to be looking at three important concepts: work, energy, and power. This is lesson 3. Now, work, energy, and power are fundamental concepts in physics that describe how forces and objects interact and cause changes in motion. Now, the first concept here is work. And what is work? Work is said to be done when a force is applied to an object and the object moves in the direction of the force. So mathematically, we have work done is equal to FD cos theta, where W is work done, which is measured in joules, and then we have F is force, which is measured in Newton, and D is displacement, which is measured in meters, and theta here is the angle between the displacement and the force. Now, the next concept we're going to be looking at is energy. Now, energy is the capacity to do work, or the ability to do work. Now, we're going to look at the basic two kinds of or the two types of mechanical energy. Now, because mechanical energy is a form of energy, that's the basic one we must consider. Now, mechanical energy has two types. The first one is kinetic energy, which we use Ke to represent kinetic energy. Kinetic energy is the energy an object possesses while in motion. So when an object is moving, it possesses kinetic energy. Now, kinetic energy is calculated using this formula: 1/2 mv squared, where you have m is mass is in kilograms, that's kg, and v is velocity, which is in meters per second. Now, that is the formula for calculating kinetic energy. Now, the second form of mechanical energy, or type of mechanical energy, is potential energy, which is calculated using mgh. Now, m here is mass, and mass is, we said, is in kg, that's kilograms, and g is acceleration due to gravity, which is usually, or most of the times, 9.8 meters per second squared. And then h is the height. So H here stands for height. And then the next thing we're going to look at is the concept of power. Now, what is power? Power is defined as the rate at which work is done, or you can say power is simply energy transferred. So power is calculated as P equals to W over T, where W is work done. Work done, we said, is in joules, and T is time, which is in seconds. Now, these are what these three concepts are all about. Now, why do we study, why do you have to understand these three concepts? Speaking of work, energy, and power, the reason is because work, energy, and power are important concepts that we must study, because they help us to analyze mechanical systems and even physical systems and engineering, as a matter of fact. So if you want to analyze systems, physical systems or mechanical systems, you will need to understand the concept of work, energy, and power. I hope you have learned a lot. Don't forget to like, to share, and to subscribe. And in case you have a question, feel free to send the question to me. Thank you for watching.